So now we get into the chapter of linear dependence, basis and dimension. Okay, we introduced the concept of linearly dependent. So let V be a vector space over a field K. The vectors v1, v2, vm in the vector space are said to be linearly dependent or linearly dependent over the field, okay, or usually we only say linearly dependent if there exist scalars a1, a2, am, obviously from the field, not all of them 0, such that a1 times v1, a2 times v2, and you get 0. If this happens, so these vectors v1, v2, vm are said to be linearly dependent. So if any of these value is not 0, okay, if any of these scalars not being 0, you do this and you get 0, so you know that these vectors are linearly dependent. Or otherwise you can say that the vectors are said linearly independent over the field, of course, or simply independent if this doesn't happen. So now in this collection v1, v2, vm, in this collection of vectors, if one of them is 0, of course the vectors will be, this set of vectors will be linearly dependent. Okay, let us say that one of these vectors in this set, let us say that this one is 0. So if this one is 0, these vectors will be linearly dependent. Okay, the proof is really easy, right? Because we have v1 plus v2 plus etc. plus vm, right? And is this 0? Well, this one can be 0, right? This one can be 0. They can all be 0. Okay, except this one. Okay, so not all of them 0. So this is 0, this is 0, they are all 0. These scalars are all 0, but this one is not 0. But the thing is that v1 is 0. Okay, so the conclusion is, in a set of vectors, if one of them is 0, the vectors will be linearly dependent. Now, an interesting question. What about an isolated vector? Is this dependent or independent? Okay, so let us say that this vector is not the 0 vector. Okay, so since v is not the 0 vector, is this dependent or independent? Well, let us write k times v, where k is a scalar. Okay, k in the field, right? So k times v, and let us say that we get 0 here. Well, that means that k is 0 or v is 0. Okay, but v, by hypothesis, v is not 0, so this cannot be 0. So the only possibility is k being 0. Okay, so the vector is linearly independent, because the only way of getting 0 here is if this k is 0. So this being said, it means that this vector is linearly independent. Okay, so a non-zero vector is always independent. Sounds a bit silly, but it's true.